Okay, here we go. Systems of linear inequalities, tutorial number 2. So last time we were graphing single inequalities. And so we're really just going to do the same thing this lesson, except for instead of graphing them each single inequality on a separate graph, we're going to graph them all together on the same graph and see where they overlap. And that's why we call this unit systems of linear inequalities. So here we go. I'm going to look at the first inequality, x is less than 5. I know I go to the x-axis. I find the 5, and I know that lines that are x equal are straight up and down. Now, I have to decide right away, do I draw a solid line straight up and down or a dotted? Since x is less than this line and not less than or equal to, I have to do a dash. So we talked about that last lesson, right? This isn't new. And then we have to decide about the shading. X is less than 5. Since there isn't a y-intercept and only an x-intercept, then we put our pen or pencil on the x-intercept and we decide what numbers are less than the x-intercept of 5, right? Because x is less than 5. Well, it makes sense. The numbers to the left are less than 5, so that tells us that we're going to shade to the left. Now, I'm going to switch up my colors for each of these inequalities. You can decide to still do it in a pen or pencil, but maybe do different, like this one do lines, the next one do squiggles. But I'm going to go ahead and change colors. And now I'm going to look at our next inequality, y is greater than or equal to 2. So I'm going to find my y-axis. I'm going to find the 2. I'm going to put that there, and I know that y equals 2 is a flat line. Since we have this inequality says y is greater than or equal to, I see that line, and it reminds me that I'm drawing a solid line here. And then for shading, I go back and it says y is greater than or equal to that line. I put my pen or pencil on the y-intercept of 2 and I say to myself, what's greater than 2? Oh, the numbers that go up, right? Which reminds me, I'm going to shade this way. Now, I'm going to shade not only in a different color, but I'm going to do like diagonal. Now, I can see that the overlap, I could stop right here, right? Because that's where it overlaps. Or I could go ahead and keep saying, well, y is still greater than 2 all through here. But I could see so far that where the purple and the green are overlapping, that's going to be part of our solution. But that's okay. You can do it either way. You can keep going with the purple. Let me switch up to a red, and I'm going to do this last one. I see that my y-intercept is 4. So there we go. And then my slope is 2, up 2 over 1. I might do that a few times to get a decent line going. Y is less than this line. It's not equal to this line. So I know connecting it, I'm going to have a dashed line. And then I've got to decide about the shading. Y is less than this line. Put my pen or pencil on the y-intercept. And I know that numbers that are less than 4 are below it, so I'm going to shade below the line. All right, now this is where it gets a little crazy. Hopefully, you did a decent job and you can tell where the overlap is going to be. So let's see. All right, can you tell on my picture where the purple, green, and red overlap? Well, I can, and I'm going to go ahead and use, what should I use? I think I'll use a highlighter to really emphasize where my answer is. So I'm going to go ahead and pick a little highlighter. Yellow is good, right? And I'm going to reinforce that, let's see, one of my parameters, one of my stopping points is this dashed red line, okay? And then also this dashed green line and the solid purple line, right? And then we've got all this stuff in between. So here's the deal. You got to figure out your own way, whether you're practicing or whether you're taking the test, so that the reader of your answer can look at it and go, oh, I see. This is where they overlap. In fact, kind of didn't like that I did that. Let's see. I want to use a real color. Let's use a pen. Let's use something bright. Let's use like bright pink. Okay. So I'm going to go back over and make it really obvious that all the pink shows my answer. That's a solid line, right? And then all of this in there. Okay, so it should look like a triangle. Hopefully you've got the same thing. All right, so what did we just do? We graphed three inequalities, and wherever their shading overlapped, that's what we're going to call the system, the solution to the system of these three inequalities. Let's try it again. All right, we've got y is less than or equal to 8. That means go to the y-axis. There's your y-intercept. Because it's y is less than or equal to, the answer can be on the line. Y is less than means that all the numbers are less than 8. That's down, so we're going to shade below the line. This time there are only two inequalities in our system. So let's go ahead and switch up the colors. I'm going to do green, and now I'm going to do y is greater than 3, so I'm going to find the 3. The y has to be greater than 3, so it can't be equal to 3. So that's where I'm going to use the dash right here. And I know that y is greater than 3 when I shade up above the line. So can you see where the green and the pink, where the green and the pink overlap? I'm going to use a different color. How about orange? That's always good. And I'm going to show that on my dotted line there and my solid line there, and all of this in between where the pink and the green are overlapping, that is the solution to this system of inequalities. That's a graphical solution to the system of inequalities. All right, let's try another one. You know, we are going to go over this, so just hold on. Don't try another one just quite yet. We're going to go over this in another lesson, but basically what we're saying is anything that you want to find that is where y is less than or equal to 8 and y is greater than 3, you're going to find with this orange mess that we see. See how this line right here is dashed? That's actually just holding the answer of the squiggles. That's not actually part of our solution. This solid line, y equals 8, is part of our solution. But we'll talk more about that in the next lesson. Or maybe even this lesson, we'll see. All right, so let's keep graphing. We've got y is greater than 4/3 x plus 7, so we know how to graph. We're pretty good at it. Since I'm running out of space going up, instead of going up 4 and to the right 3, I'm going to do the opposite. I'm going to go down 4 and to the left 3. We're allowed to do that. We end up with the same thing. Y is greater than this line. There's no equal to part of it, so I have to do a dashed. Y is greater than, and greater than means up from 7, so I know that my shading goes up. Okay, let's switch colors. Let's go purple, and let's do this. And this is where we're like, uh-oh, we got to do a little extra work, don't we? So we did this in our last tutorial. We can do it again real quickly. I want to get y by itself, so I'm going to go ahead and subtract the 4x from both sides. I bring down my negative 3y. Don't forget that negative. That's part of the 3y. I bring down my greater than or equal to, and then instead of writing 24 minus 4x, I write negative 4x plus 24. We've talked about y a couple different times already. And I'm almost done, right? I'm going to divide my y by negative 3, which means I've got to divide all my terms by negative 3. And that cancels out, and that's right, I can hear you. We divided by a negative. We got to switch the inequality, and we do. So the greater than or equal to, it's less than or equal to. We've talked about this. When you see negative over negative, that cancels out. We don't want to turn 4/3 into a decimal because we like slopes to be fractions, not decimals. At least when we're graphing, right? So we have 4/3, makes graphing easier. And then 24 divided by negative 3 is negative 8. So we're going to go ahead and graph that. Our y-intercept's negative 8. Our slope is up 4, 1, 2, 3, 4 over 1, 2, 3. We can do that a couple times, 1, 2, 3, 4 over 1, 2, 3. Do we make this a solid or a dotted line? Let's see, we're going to make it a solid line because we have the equal. I know you guys were probably noticing the same thing. My line's a little curvy, but look at that. These two lines are parallel. And that makes sense, right? Because the slope of the first line is 4/3, and the slope of the second line is 4/3. So let's go back to shading. Y is less than or equal to. So less than, if I go to my y-intercept, the numbers that are less than negative 8 are down. So we're going to shade down. And when we do that, do we have any overlap? No, none at all. So graphically, we can just see looking at the picture, there's no overlap. We could also write no solution, but our graph really tells us that there's no solution. We see that there's no overlap. Okay, so let's look at the next one. We've got 3 to graph. Once again, this one's going to need a little bit of work, so I'm going to bring that down here. I've got x plus 2y is less than 6. I'm going to go ahead and subtract x from both sides. I'm going to rewrite it with the x term first. I'm being careful to put that plus in front of the 6 because the 6 is positive. Divide everybody by 2, but because 2 isn't negative, I don't need to switch the inequality sign. That cancels. Now, I know what you're thinking. This negative x over 2, well, what's the slope? Well, it's really easy to see, I think, when we think about it. Negative x is the same thing as negative 1x. And when we do that, it's easy to see that our slope is negative 1 over 2. 6 divided by 2 is 3. Let's go ahead and graph that. We've got a y-intercept of 3, and our slope is down 1 over 2, down 1 over 2. Can we do solid or dotted? We've got to do dotted, right? Because the line is less than, y is less than. So let's go ahead and do a dashed line. And since y is less than, our shading, we look at the y-intercept, less than 3 means down, so our shading is going to be down. Some people like to wait to shade to the very end. And to those people, I say, stop it. Usually, if you wait to shade till the very end, it's so confusing that you might get it wrong. Now, there are a few people out there that do it great, so just reconsider, make sure you're always getting them right if you're choosing to shade at the very end. All right, this next line is pretty easy to graph. We know our y-intercept is 7. Our slope is down 2 over 1, down 2 over 1, down 2 over 1. I want to do it a couple times. I don't know why. It's very comforting to keep doing the slope over and over again. It's mind-numbing, right? All right, so can we do a solid or dotted? That's right, we're doing a dotted or a dashed because it's not really dotted. We're kind of dashing it up. Ooh, I don't even know what that thing's doing there. All right, and y is less than, so I go to my y-intercept. The numbers that are less than 7 are down below, so I'm going to shade below. We can already see where the green and the purple are overlapping, right? All right, and let's switch to a new color. Let's switch to red. And we've got a little bit of work to do with this one, right? I'm going to go ahead and distribute the 1/4. 1/4 times negative 2 is going to be what? Negative 1/2. If you wanted to do negative 0.5, so I think the majority of you guys, 1/4 x. I think the majority of the students that I work with, when they're combining like terms, would rather combine with a decimal than a fraction. So negative 0.5 minus 1 is negative 1.5. So this is going to be interesting, right? Our y-intercept is going to be negative 1.5. So we'll go down 1.5. We can do this, right? Because from here, our slope is up 1 over 4. Now watch, up 1 is going there, right? And that's not really one of our points, but I'm just showing you. Our slope is up 1, then over 4. 1, 2, 3, 4. So there's 1. And if we go up 1 again, it's there. That's up 1. And then 1, 2, 3, 4. All right, so these points, these big points, are actually part of our line. The other ones were just showing you how I was going to get the slope, given that my y-intercept wasn't on a corner point. All right, so y is greater than or equal to this line. So since we see the equal to, we know we're going to do a solid. And y is greater than, so I put my pen on or pencil on the y-axis, and I know the numbers that are greater than my y-intercept are up. So I'm going to start shading up. Now, I know what you're saying. Miss Overby, you don't really need a shade right there. And you're right, that's not going to be part of the solution. But it is part of this solution, right? So we're going to see, hopefully it doesn't get too messy. Hopefully we can see where all the purple and the green and the red are overlapping. And you know what? Feel free to, if you're doing this video in the classroom, feel free to use some markers. All right, I'm going to switch to, let me see, what color do we have that I can switch to show the final product. How about a super bright green? Okay, so here we go. Let's see where the overlap is. I think this red line is part of the overlap, right? And then, ooh, did I go too far? I did go too far, so hold on. Let's see. The green, this is kind of crazy. Let's see. I think the green is part, let's see, if the green is there, then this part right here is part of it. Then the purple is part of it, right? And then the red, let's see, do I have any purple there? Do I have any green there? Yep. So then the red right here is part of it. And then all this is part of it. So hopefully I got that right. I think sometimes when I'm using the smartboard, the graph is so big, it looks very confusing. So if I made a mistake, please tell me in class. But I do believe that that is your answer. It's got a little turn in there somewhere. All right. Not bad, right? This is just about doing our single inequalities together and seeing where they overlap. All right, so our last one is going to be doing this backwards. So it says, which of the equations represent the following system? So instead of graphing, we're looking at the graph and deciding what fits what. All right, we can see, because we can see that really we're dealing with the same lines, right? 2x minus 5, 2x minus 5, 2x minus 5, 2x, negative 2x minus 5. Let's start there. So let's see, minus 5, and I know it's tough to see, but that looks like minus 5 there. And this blue slash line looks like up 2 over 1, right? Up 2 over 1. So our slope is a positive 2. So right away we were like, without even thinking about the shading part, we know the slope is wrong for this. That does not describe the line that we see. All right, we can also probably see that if we're looking at this line, we see shading that is above it. So see the red is just the final answer. They erased all the other stuff. The red is the answer where they all overlapped. So we know that since the red is above the blue line, then we know that the shading for it was greater than the line, right? So this one, we're still good. This one, y is less than that line. Nope, this one's out. Oh my goodness, look at it. We were able, just looking at one line, to tell what our answer is. So let's double check that this is also right. The line y equals negative 1/2 x means the y-intercept is 0. And that's true. Let me switch colors. And that's true. And then the slope is down 1 over 2, down 1 over 2. So that's true. And then it is a solid line, and that's true. That looks like a solid line. And the shading is down, which would be less than or equal to. So this is our answer. So hopefully that gave you a little, it's just a mini lesson, right? I think the real learning and retention happens when you're able to practice yourself and ask questions. All right, thanks for joining me. See you in class.